Good afternoon, good evening, good morning, depending on where you are. This is what we did last time. We're giving this to verify. We stopped here and there was a promise that today the verification will be done. This is an associative law. We want to verify that the left-hand side is equal to the right-hand side if given the following matrices. We've been taught how to carry an operation of multiplication when given certain matrices. We are given matrix A, B, and C, and we're told as well that in order for two matrices to be multiplied, the number of columns in the first matrix must be equal to the number of rows in the next matrix. Like I told you the last time we taught here, you have to consider what is in the bracket first. Now let's go. Our solution to what is on the board, first do what? Multiply B and C, that is BC. This will be equal to, this is B and this is C. Picking the first row to multiply the first column in the next matrix. 1 times minus 1 plus 7 times 2 plus 0 times 0. Still use that first row to multiply the next column. 1 times minus 1 plus 7 times 0 plus 0 times 4. Pick the next row, which is minus 1, minus 3, minus 1 and 0, minus 3 times minus 1 plus minus 1 times 2 plus 0 times 0. You still use that row to multiply the next column. Minus 3 times minus 1 plus minus 1 times 0 plus 0 times 4. Continuing with the last row, 1 times minus 1 plus 0 times 2 plus 5 times 0. Right? The next one, 1 times minus 1 plus 0 times 0 plus 5 times 4. All enclosed in the brackets. Now, 1 times minus 1 is minus 1. 7 times 2 is 14. That is minus 1 plus 14. This is gone. That is 0 times 0 is 0. So here we have minus 1 plus 14 will give us 13 here. Then for this, minus 3 times minus 1 is plus 3. We were told in elementary mathematics that minus times minus is plus, minus plus minus is minus, minus plus minus is still minus, and minus times plus is minus. So minus 3 times minus 1 is plus 3, and minus 2 times plus 2. Here is 0. So by implication, our answer here should be 1 because 3 minus 2 is 1. Now the next one is 1 times minus 1 is minus 1. 0 times 2 is 0. 5 times 0 is 0. Remember, 0 times any number is 0. So the answer here remains minus 1. Then, coming down to this side, 1 times minus 1 is minus 1. 7 times 0 is 0. 4 times 0 is 0 still. So we have minus 1 here. Then, minus 3 times minus 1 is plus 3. Minus 1 times 0 is 0. 0 times 4 is 0. So we have 3 here as our answer. Then 1 times minus 1 is minus 1. 0 times 0 is 0. 5 times 4 is 20. Now minus 1 plus 20 is 19. So for our A and BC, it is 13 minus 1, 1, 3, and 1, and then 19. Having gotten that, we'll now go back to use A to multiply this, that is BC. Now let's go. A times BC will now be, that means we use A, remember, the conditions must be ascertained before you go ahead. Number of columns there, 1, 2, 3. Number of rows there, 1, 2, 3 as well. Now 1 times 13, 1 times 13 plus, minus 1 times 13, then plus 0 times 1 plus 5 times minus 1. 5 times minus 1. Still go ahead, multiplying the second column. Minus 1 times minus 1 plus 0 times 3 plus 5 times 19. We are done with that. We pick the second row. 7 times 13, 7 times 13 plus minus 2 times 1 plus 0 times minus 1. Next, 7 times 0 plus minus 2 times 3 plus 0 times 19. All enclosed in a bracket. Now, minus 1 times 13 is minus 13. This is 0 because 0 times 1 is 0. Now 5 times minus 1 is minus 5, giving us minus 13 minus 5 is minus 18, because minus plus minus is minus. So we have minus 18 here. 7 times 13 is 91. Then minus 2 times 1 is minus 2. This is 0, because 0 times minus 1 is 0. 91 minus 2 is 89. Now minus 1 times minus 1 is plus 1. This is 0. 5 times 19 is 95. So 1 plus 95 will give us 96 here. Then coming down, 7 times 0 is 0. Minus 2 times 3 is minus 6. So our answer here is minus 6. I hope we're on track. So we have gotten our A times BC. That is our left-hand side. So we're going to check if what we have at the right-hand side will be equal to what we have already gotten at the left hand side. If at the end of the day they are the same, we have been able to do what? Verify the associative law. Now let's do that of A and B, that is A times B. Let's continue. AB equal to, this is A, this is B, minus 1 times 1 plus 0 times minus 3 plus 5 times 1. Go again. Minus 1 for our AB, minus 1 times 1 plus 0 times minus 3 plus 5 times 1, then minus 1 times 7 plus 0 times minus 1 plus 5 times 0. Now for our AB, we have minus 1 times 1 plus 0 times minus 3 plus 5 times 1. The next column, minus 1 times 7 plus 0 times minus 1 plus 5 times 0. The next one, minus 1 times 0 plus 0 times 0 plus 5 times 5. We are done with that. We'll pick up the next row. 7 times 1 plus minus 2 times minus 3 plus 0 times 1. Then 7 times 7 times 7 plus minus 2 times minus 1 plus 0 times 0. Now the last column, 7 times 0 plus minus 2 times 0. Sorry. Look at another example. If A is a square matrix, that means that A can multiply itself. Then A squared, that is A raised to the power 2, equal to A is defined. Now, if given A as 1 minus 3, 0 and 4, compute for A squared. It's simply duplicating this. A squared equal to 1 minus 3, 0 and 4 times 1 minus 3, 0 and 4. Going forward, 1 times 1 plus, remember, in multiplication of matrices, we use row to multiply column. 1 times 1 plus minus 3 times 0 minus 3 times 0. Still use that same row. 1 times minus 3 plus minus 3 times 4. The next row, 0 times 1 plus 4 times 0. Then 0 times minus 3 plus 4 times 4, all enclosed in a bracket. 1 times 1 is 1. This is 0. This is 0. This is 0. That is 0 times 1 is 0. 4 times 0 is 0. Anything multiplied by 0 is what? 0. We have 0 here. 1 times minus 1, minus 3 rather, is minus 3. And minus 3 times 4 is minus 12. Minus 3 minus 12, that is minus 3 plus minus 12 will give us minus 15. 0 times minus 3 is 0. 4 times 4 is 16. Therefore, a squared equal to 1 minus 15, 0, and 16. It is very simple and very interesting. What if you are given something like this to compute in a situation where A is giving us 1, 3, 2, and a 0, and you're asked to find a squared plus 3a plus I, where I is a unit matrix of order 2. A unit matrix of order 2. Recall that a unit matrix is a diagonal matrix with 1 are the diagonals and 0 x squared. Now, computing this solution, our A is equal to, remember in mathematics we don't say equals to. When you're finding a relationship between two things, you don't say equals to, you say equal to rather. So we have here 1, 3, 2, and 0. Our A squared will be the duplicate of this A, which is 1, 3, 2, and 0. Now let's go. 1 times 1 plus 3 times 2, 1 times 3 plus 3 times 0. Pick up the second row, 2 times 1 plus 0 times 2. Still use it for the next column, 2 times 3 plus 0 times 0, all enclosed in a bracket. 1 times 1 is 1, 3 times 2 is 6, 1 plus 6 is 7, then 2 times 1 is 2, 0 times 2 is 0, you have 2 here, then 1 times 3 is 3, 3 times 0 is 0, 2 times 3 is 6, 0 times 0 is 0. Therefore, we have our A squared to be 7, 3, 2, and 0. We have gotten a value for A squared. Now, let's go forward to get that of 3A. Now, for 3A, it is simply using 3 to multiply the contents or the entries in matrix A. So for 3A, it is simply what? 3 times 1, you have 3. 3 times 6, we have Sorry, 3 times 3 is 9. We equally have another one. 3 times 2 is 6. 3 times 0 is 0. Then, for our unit matrix, I is 1, 0, 0, and 1. Now, substituting all that we have gotten into a squared plus 3a plus I is simply this. What we have as our a squared is 7, 3, 2, 0 plus 3a. We have our 3a as 3, 9, 6, and 0 plus 1, 0, 0, and 1. Recall that you were taught in a matrix addition that we add the corresponding element. Now, to carry out our addition here is simply adding the corresponding element. Now, 7 plus 3 is 10. 2 plus 6 is what? 8. 3 plus 9 is 12. 0 plus 0 is 0. We have gotten this. Now, still plus the unit matrix, 1, 0, 0, and 1. Now, we have 10 plus 1 is 11. 8 plus 0 is 8. 12 plus 0 is 12. 0 plus 1 is 1. Therefore, a squared plus 3a plus I equal to. Very simple. We have really done or covered a reasonable ground here. Let's go further in what we call transpose. The transpose of a matrix. We don't need much, or I don't need to say much on transpose of a matrix. The transpose of a matrix is simply interchanging row for column and column for a row. It is denoted by this. Now let's look at this example. If you have A equal to 3, 9, 6, and 5, find A transpose. A transpose is simply interchanging row for column and column for row. Now this is row 1 becomes 3, 9. You can see that it is now in column before it was a row. Now this row 1, row 2 becomes column 2, 6, and 5. It is as simple as that. We don't need to spend so much time here. It's just interchanging row for a column and column for a row. Having said that, determinant. Determinants of a matrix can only be computed if it is a square matrix. Recall that we've been told that a square matrix is a matrix where the number of rows and columns are equal. Now, coming down to the determinant of a matrix, we can only compute for the determinant of a matrix if it is a square matrix. Taking for example, if you have A equal to A, B, C, and D, and you are asked to find the determinant of A, this is how we denote the determinant of A. In some books, you may come across that A. It means the same thing with this, but I prefer to use the absolute A. This is how we describe the determinant of A. Now, to find the determinant of what these entries, it is simply A A times D minus B times C. All these things are very simple. We're going to make use of figures for clearer understanding. Now, what if you are given this? Let's say you have 2, 4, 1, and 3, and you're asked to find a determinant or the determinant of A. What do? Taking a clue from what I just showed you now, solution, a determinant or the determinant of A for this given matrix is simply 2 times 3 minus 4 times 1. 2 times 3 is 6. 4 times 1 is 4. 6 minus 4 is 2. Therefore, A determinant equal to 2. This is order 2 by 2. Let's proceed to order 3 by 3 to find the determinant. If given A11, suffice it to say 3 by 3 matrix. Let's look at how we can find the determinant of a 3 by 3 matrix if A equal to A11, A12, A13, A21, A22, A23, A31, A32, A33, and you're asked to find the determinant of A. Please follow me closely. It is very interesting. It is something you can easily compute. Now, to get the determinant of A in a 3 by 3 matrix, we start with a positive sign, and the next one is a minus. We alternate the sign, positive, negative, positive, as the case may be. Now, when you pick A11, this is the row where A11 is found, and this is the column where A11 is found. So if you are going for the numbers for A11, you don't touch any number on that column where A11 is, and you don't touch any number on the row where A11 is. So it is this. It will now be A11. See the elements. See, you can see how my hand. It will now be A22, A23, A32, and A33. So here we have A22, A23, A32, A33. The next one is A12. I told you we alternate the signs is a standard. So the next one will now be A, that is minus A12. What we did here is the same thing we'll do here. The row where A12 is, you don't pick any entry there. The column where A12 is, you as well do not pick any entry there. On that note, see my hand again. It's going to be A21, A23, A31, A33. So the entries for A12 will now be A21, A23, and A31, A33. We are done with that. We'll go again. The next one is A13. Remember, we alternate the signs. The next one should be plus A13. See the column where A13 is. Don't touch anything there. Do not touch anything on the row where A13 is. On that note, we have the entries as A21, A22, A31, and A32. So we have A21, A22, A31, A32. Now, to get our determinant, you now pick the first one, A11, A22 times A33 minus A23 times A32 minus A12, bracket open. This is minus A12, the second one. It will now be bracket open, A21 times A33 minus A23 times A31. Anything it gives us becomes the value for the determinant. Now we're going to use figures so as to have a clearer understanding of what we're talking about when it comes to 3 by 3 order of matrices in finding a determinant. Now, if given A as 2, 1, 2, 3, 4, 5, let's say 6, 2, and 1. Find a determinant. Let's do it. It is very simple and interesting to do. Now, for a determinant solution, you have A equal to 2, 1, 2, 3, 4, 5, 6, 2, and 1. Want to find a determinant. A determinant equal to, you pick the first one, 2. The entries or the elements for this should be, see my hand, 4, 5, 2, and 1. You pick the first one, which is 2, and the numbers on the same row with 2, you do not touch. You do not touch them. And the numbers on the same column with 2, which stands to be our A11, you as well do not touch. So we have 4, 5, 2, 1. The next one, minus 1. That is the second number here. So you don't touch anything here on this column, and you do not touch on this row. So we have 3, 5, 6, and 1. Then plus the next one is 2. You have still do not touch this row and this column. 3, 4, 6, and 2 equal to, bracket open, 4 times 1 is 4, minus 5 times 2 is 10, minus 1, 3 times 1 is 3, minus 5 times 6 is 30, bracket close, plus 2, 3 times 2 is 6, 4 times 6 is 24. Now, 4 minus 10 is minus 6, minus 1, you know, is there. 3 minus 30 is minus 27. We have plus 2 here. 6 minus 24 is minus 18. Right? Continue. 2 times minus 6 is minus 12. Minus 1 times minus 27 plus 27. Plus 2 times minus 18 minus 36. Now, plus minus 12 plus 27 minus 12, that is to say 27 minus 12 is 15. Now you have a 15. Permit me to use this side of the board. Continuing here, you have minus 12 plus 27, which is plus 15 minus 36. Now, subtracting a bigger number from a smaller number will leave the answer in a negative form. So 15 minus 36 will give us 21. Therefore, a determinant equal to minus 21, because we are subtracting a bigger number from a smaller one, which is not supposed to be, which is an error. Therefore, it has the answer to be in minus form. So 15 minus 36 will give us minus 21. That is that for determinant of a given matrix. We will also briefly look at please, before we move over to another thing, I want to drop something you will play with at your leisure. You play with it so as to keep what we are doing here fresh in your memory. Please try this at home. Given B equal to 1, 2, 3, 5, 4, and 1, 3, 0, 6. Find B determinant. Now, let's move over to solution of simultaneous linear equation. Simultaneous linear equation. Here we are going to be making use of a rule called the Cramer's rule. We consider the Cramer's rule. Cramer's rule. We use that rule to solve here. Now, let's solve A1x plus B1y plus C1z equal to D1. Now, A2x plus B2y plus C2z equal to D2. Then A3x plus B3y plus C3z equal to D3. Now, we have to solve this. Before we start making use of figures, we are going to derive a formula we'll be using to get the values of x, y, and z. Now, given this, let D equal to A1, B1, C1, A2, B2, C2, A3, B3, C3, all enclosed. This is A. This is D. This D means determinant. D equal to this, or let's make use of this other side. Or XD equal to A1X plus B1Y plus C1Z, you have B1, C1 here, A2X plus B2Y plus C2Z, you have a B2C2, B1C1, B2C2, then A3X plus B3Y plus C3Z, you equally have B2C2. Now, it implies that our X is equal to D1, B1, C1, D2, B2, C2, D3, B3, C3, all over A1, that is this D, all over this D, that is the Cramer's rule we're talking about. A1, B1, C1, A2, B2, C2, A3, B3, and C3 equal to D1. Our D1 is X all over D. Then for Y, if by implication we have our X, which is D1, to be this, it implies, or similarly, our Y equal to A1, D1, C1, A2, D2, C2, A3, D3, C3, all over A1, B1, C1, A2, B2, C2, A3, B3, C3 equal to D2, which is Y, all over D. Then, for Y, the last one is Z. Please, these things should be at your fingertips, because when you're solving with numbers, you need to recall all of this in order to get your answers or the values for X, Y, and Z. Now, Z equal to A1, B1, D1, A2, B2, D2, A3, B3, D3, all over A1, B1, C1, A2, B2, C2, A3, B3, C3 equal to D3 all over D. Therefore, X equal to D1 all over D, Y equal to D2 all over D, and Z equal to D3 all over D. This is what we mean by Cramer's rule. We're going to equally solve with figures for a clearer understanding. Solve the 6x minus 8y plus minus z equal to 15 and 3x plus 2y minus 6z equal to 7. Now look at these equations. The coefficient of x here is 5. What do we mean by coefficient? That is the number that is attached to x. And the coefficient of the coefficient of y is minus 7, while the coefficient of z in the first equation is 1. By implication, our A11 is 5x, our A1 is 5x, B1 is minus 7, and C1 is 1. D1 is 11. Our A2 is 6x, and our B2 is minus 8y, while our C2 is minus 1. Our D2 is 15. Then our A3 is 3x, B3 is 2y, C3 is minus 6z, and D3 is 7. Having done determinant, you have to use determinant to get the values for D, which is determinant, the values for D1, D2, and D3. I believe you won't find this difficult because it is still the same method we used in solving determinant you will use to solve these simultaneous equations using the Cramer's rule. Now let's solve and see. We first get a value for our D. D equal to, remember from the structure I gave you, the D is A1, B1, C1, A2, B2, C2, A3, B3, and C3. Now coming to these equations, our A1 here is 5. Our B1 is minus 7. Our C1 is 1. Then B2 is 6. A2 is 6. B2 is minus 8. C2 is minus 1. A3 is 3. B3 is 2. C3 is minus 6. We have to find the determinant, the D, first. When we are done with that, we get for X, Y, and Z. From there, we divide and get the final answer. Now, just as I taught in the determinant of a matrix, you pick the first number, which is 5. You don't touch anything on this column. You don't touch anything on this row. You have minus 8 minus 1, 2 minus 6. The next one, remember the standard, minus, minus. It then means here will automatically becomes what? Plus, because minus times minus is what? Plus. May we not write like the elementary children? So let's go ahead and write our plus sign there. Plus 7. You don't touch up here. You don't touch this column. So we have 6 minus 1. 3 minus 6. Then the last one is plus 1. You have just here 6 minus 8, 3 and 2. Now, the first one, five into minus 8 times minus 6 is 48, because minus times minus is plus. Now minus. Remember, there is an already existing minus in between. So here is going to be plus, because minus 1 times 2 is minus 2. Now minus times minus is plus 2. Here is plus 2. You are done with that. Plus 7. 6 times 6 is 36. Minus 1 times 3 is minus 3. Remember, there is an already existing minus there. Therefore, minus times minus is plus. So we have plus 3 here. Then the next one, plus 1. 6 times 2 is 12. Minus 8 times 3 is minus 24. Remember, there's an already existing minus there. Therefore, minus times minus is plus. Here becomes plus 24. Now, let's continue here. 48 plus 2 is 50. We have 5 into 50. 36 plus 3 is 39. Then we have plus 1. 12 plus 24 is 36. Now, 5 times 50 is 250. Plus 7 times 39. This is 3. This is 21. That is 27. We have 273 plus 36, because 1 times 36 is 36. 250 plus 273 is going to give us 523. 523 plus 36. So this is going to give us 559, equal to 559. We are going to stop here. When next we meet, we'll continue from here. Meanwhile, before our next class, do well to go through all that we have done so as to keep it fresh in your memory. And also remember to click on the subscription button in order to receive every lesson that is being taught on this channel. Thank you for your time. Bye.